Alright, so there is the physics class. Alright, so let's see what we have to do. Today we are going to discuss the concept of wave motion. Wave motion. So you pay rough attention and then contribute. Because there are some things that are related to what we have been doing previously, specifically on circular motion. So when the time comes and I ask you something about circular motion and then you don't respond, you'll be in trouble. Yes, alright, so now let's look at wave motion. Now basically, any motion that a wave produces is wave motion. So first we'll talk about waves, see what a wave is, and then see some two things about it, and then we'll move on to wave motion itself, and then describe how a wave motion looks like. So first, let's talk about waves. So waves, waves. So let me ask the class: any idea that you have about a wave? Any wave you know about? Say something. You have heard of the word wave before. So ordinarily, what's a wave? Ordinarily, if you are asked what a wave is, what are you going to say? Yes, Percy.
A wave is a traveling disturbance which carries energy across a medium.
A traveling disturbance which carries energy across a medium. Okay, that's nice. Any other idea about what a wave is?
That's a wave that don't carry.
Don't worry, we'll come to that. But currently, I want to know what a wave is in general. So tell me your idea of what a wave is. Someone said it's a traveling disturbance which carries energy through a medium. Any other idea of what a wave is? Before I wrap up on that. Alright, let's go on. Now, whenever you disturb any medium, whether it's a material medium or a vacuum, the disturbance you create in the medium is going to transfer energy, or the medium is going to carry the energy of the disturbance through it. Now that traveling disturbance through the medium, which carries the energy from one point to another in the medium, is what is called a wave. So for example, if I have a bowl of water and I leave or I drop a small coin into the bowl, I will disturb that portion of the bowl. Now my disturbance is going to transfer or travel through the water. And that traveling disturbance is what is called a wave. Now, it doesn't only travel through the wave, it also carries the energy from where I disturbed throughout the bowl of water. So if I have a leaf on the water surface, you will see that at one point in time, the leaf will bounce up and down. Because when the wave gets to the leaf, it is going to cause the leaf to vibrate. So there are two important things you must know about a wave. One is that it is a traveling disturbance. And the other important is that it carries energy. Through the medium. And then it causes a temporary disturbance of the medium. In other words, it causes the medium to move temporarily. Is it clear there? So it also creates temporal disturbance or temporal movement. So if you want to describe a wave, you can use these three concepts to describe it. One is that it's a traveling disturbance. Two is that it carries energy through the medium. And then three is that it creates a temporal movement of the medium. Is it clear there? Yeah. So we combine that to describe what a wave is. So you can put something down now. A wave. A wave is a traveling disturbance A wave is a traveling disturbance which carries energy through a medium. Which carries energy through a medium. Without a permanent displacement. Without a permanent displacement of the medium. I hope that's clear there. So whenever you are asked to explain what a wave is, at least these three important points here should be found in your definition. It's a traveling disturbance, it carries energy through the medium, and then it creates temporal movement, but not permanent movement of the medium. Is that clear there? Now, this temporal movement means that the medium is going to experience motion. Now, the medium is made up of particles. Now, the overall movement of the medium, if it is water, what you see the water doing, which you call a wave, is as a result of the individual movements of the particles of the medium. So if it's water, for instance, the particles of the water are going to vibrate. Each particle will experience a vibration. And then the general or the total vibratory motion of all the particles is what will constitute how the medium behaves. So, for example, if I am to draw a wave that occurs on water, for instance, I will see something like this as a wave or as a water wave. Now, the particles of the water will have what we call an equilibrium position. When the water was at rest or when it was still, this will be its level. So if I am to indicate, let's say 1, 2, 3, 4, 5, 6 particles of the water, then whenever the wave gets to, the particle there is going to experience a vibration. So this particle will move to this point of the wave. This particle will move to this point. If there is one here, it will come here. If there is one here, it will remain at that same point. The particle here will move down here in accordance to the wave. This particle will migrate to this point. A particle here will come there. This one will move up there. This one will be just there. If there is one here, it will move up here. A particle here will migrate downwards to this end. So the overall waveform that I see on the water is actually a net movement of the vibrations of all the particles in the water. So whatever waveform you see, whatever wave pattern that you see, know or bear the facts in mind that it's as a result of the individual vibrations of the particles that make up that particular medium. Do you follow that there? Now that vibrational motion or the vibratory motion of these particles is what constitutes a wave motion. So basically, wave motions consist of vibrations of the particles of the medium. However, the waveform is, if it is like the water wave I have drawn here, it means that the particles of the medium move in such order to create that particular waveform. Do you follow that there? So every wave motion actually consists of vibrations of particles, and the vibrations are caused by the wave as it travels through the medium. I hope that's clear there. So it's important to understand when we talk about wave motion, if you go into critical detail, then you will see that it's actually the vibrations of the particles of the medium in accordance to how the wave is being propagated or is being transferred through the particular medium. Is it clear there? So we are going to see how to describe this wave motion. We can describe it. There are some terms that we can use to describe the wave motion. In other words, the vibration of the particles in the medium. We can describe it using certain terms. So let's look at description of wave motion. Description of wave motion. And we'll do that with reference to our diagram here. Now, to describe any wave motion, there are some terms that we can use to do that. And let me list those terms down and we can talk about them. We can talk about displacements. We can talk about amplitude. We can talk about crest. We can talk about trough. We can talk about wavelength. We can talk about period. We can talk about frequency. We can talk about velocity. And we can talk about phase of vibration. So we are going to describe these simple terms here in order to use them to describe the wave motion in general. So we'll take them one after the other and then discuss it. First, let's take the displacement. Displacement along a wave motion. Now, generally, what is displacement? Generally, from your studies of linear motion, what is displacement? What is displacement? Yes, I don't.
Displacement is the distance covered by body in a particular direction.
So it is distance covered in a particular direction. Now, in wave motion, we are talking about the particles of the medium and their vibrations. So during that vibration, the distance any particle travels from its equilibrium position is its displacement. If I want to talk about particle A, for instance, it moves in this direction to this point. So the displacement of A is its distance from its equilibrium point to where it gets to. Is it clear there? So you can define the displacement of a particle there as the distance traveled. The distance traveled by the particle. Distance traveled from the equilibrium position. Distance traveled from the equilibrium position. So it's important to understand whenever you are talking about the displacement, it is not to the equilibrium position. It is always from. It means it begins from the equilibrium position to wherever the particle is. So there is a specified direction. It is from the equilibrium point to wherever the object or the particle is. Is that clear there? So that's the displacement. What is the SI unit for displacement? Generally. SI units for displacement generally. Miles. Pardon? Meters. So displacement here too has the same SI unit, which is the meter. So know the definition for the displacement and then the SI units as well. I hope that's clear. Alright, now let's go on to the next thing, the amplitude. The amplitude. The amplitude. Now, if we come to my diagram here, you will see that the particles don't move to the same level. Look at A. This is where A is. Let's look at this particle B. Look at where it moves to. So the particles have different displacements along a wave. Is it clear there? Now, the maximum displacement or the higher displacement of the particles along the wave is what is termed as the amplitude of the wave. Is it clear? So the highest displacement, so amplitude is the maximum displacement. Amplitude is the maximum displacement of particles along a wave. the maximum displacement of particles along a wave. Since it is displacement, that the same units as displacement, meter. I hope that is clear. Alright, so note that as well. Then to the next thing, the crests. The crests. The crests. The crests. Now basically, if you look at the particles along the wave, they migrate the wave. So the particles have their own positions along the wave. Particle A will come to this position. Particle B will come to this position. This particle will remain here. This particle will migrate to this position. Now the highest position attained by the particles along the wave is the crest. Is it clear there? So the crest is the highest position attained by particles along a wave. The highest position. That is the crest. Yes.
What is the difference between amplitude and crest?
Amplitude is distance or displacement. Crest is position. So this point, the highest point or highest position is the crest. But the distance measured from the equilibrium point to the crest is what is amplitude. So crest is the highest point along the wave. But the amplitude is actually a displacement along the wave. Is that clear there? Alright. Now the next time, the trough. The trough. The trough. Now if we have highest position, we can also have lowest position. Now the lowest position is what is referred to as the trough. So the trough is the lowest position of particles along a wave, or the lowest point along the wave is the trough. So know about the crest and the trough. Is it clear? Alright, now the next thing, wavelength.